So for these two here, let's just do number one. We are looking for the pounds of water that this tank will hold. So we need to find the volume. Well, our base is just this shape up here. That is just a trapezoid. So the area of that base, the area for the trapezoid, how do we find the area of a trapezoid? Perfect. So 10 plus 18 divided by 2, and then times, careful, you're thinking volume. We're not, the 6, the height of the, we're still just on the base here. This is the 6 right here. Right? This is the 18. So, what do we get there? 84, I believe. I'll let you guys double check. It's been one of those mornings. 84, perfect. So for our volume, then, we take that 84 and we do what with it? Times the 30, which gives us inches cubed. Good. Well, we weren't asked for the volume. We were asked for pounds of water. We don't have a conversion from cubic inches to pound, but we do have a conversion from gallons of water to pounds. So we have to take that 2,520 cubic inches and turn it into gallons. Does anybody remember the conversion between cubic inches and gallons? You're close. 231. Well, since that's on bottom, we're going to divide. 10.91 gallons, okay? Now, I don't think I've given you guys this conversion yet, but 1 gallon is pretty close to 8 pounds. 1 gallon of water, at least. So what does that give us? 87.28, I'm thinking. Does that look right? Yep. So 87.28 pounds. Now that's now gas and water are fairly close. Gas is actually a little bit lighter than water. That's why if you put gas on water, you can see that film on the top. But gas and water are fairly close to the same weight. This is only basically an 11-gallon tank. Imagine when some of the old Suburbans where you had like a 24 and a 28, where you have 50 gallons floating on there. You're looking at close to 500 pounds, 450 pounds of gas in that thing. That's why they would get like 2 miles to the gallon better when they were almost empty than they would when they were full. This other one over here, we're asked how many kilograms of water this tank would hold. And I did intend to leave those in inches. That's intentional. So we need to find the volume of this to do. You know, I'm not going to draw it? That's fine. I understand. It was a stretch for me to draw it. That is our base right there in blue, so we need to find that area first. What I'm going to do is I'm going to pretend it's just a full trapezoid like that. How would I find the area of that trapezoid? Base plus base. So I've got the 10 plus the 22, divide by 2. But I need to know the height. Don't know the height, do I? But I'm given that this is 10 here. So we're going to assume that this 22 is split evenly. So what's the difference between the 10 and the 22? 12. So 6 and 6. Very good. So that red triangle there is 6 inches here, 10 inches here. How do I find that? Yep. Now the 10, is that a leg or a hypotenuse? Hypotenuse. So are we adding or subtracting? So 10 squared minus 6 squared gives us that other side squared. which comes out to be what? 64 equals x squared, so x is 8. Very good. So this is 8 inches in height. So our height is 8 inches. So 10 plus 22 over 2 plus 8. It's 128. So that's the area of that trapezoid. We still have to subtract out the half circle here. Now, we need to know the radius to find the area, right? What's the radius? How'd you get 5? Perfect. Okay, you got 7 and 7 here. Subtract that from the 22 is going to give you, oh, 10 does not work. A little smaller. So you got 7 here, right? That's labeled as 7. Oops. Nope, 6 inches is from here. This, okay, here's what's confusing you. This point here and the circle don't touch. The circle is not straight up and down from that edge. Does that make sense? So the 6 for the triangle came from here. That's the difference in these sides. 4 would be the radius, yes. Because we got 7 inches here and 7 inches there, that's 14 from the 22 would leave us 8. So we got a diameter of 8, radius of 4. So that gives us an area, pi times 4 squared, but we got to divide by 2. So it becomes 25.12 square inches. Do we add those two? Subtract them. 102.88 square inches is the area of our base. And then what? Times 35. 3,600.8 cubic inches. Okay, so now the fun starts. Anybody remember the conversion between inches and centimeters? 1 inch equals 2.54 centimeters. This is not inches, though. It is cubic inches. So what do I have to do with this? I have to cube it. Perfect. 2.54 cubed is 16.39. So I had to take the 2.54 cubed is where that 16.39 comes from. It's actually like 7 or 8 decimal places long. Well, 6 decimal places long, actually. But anyway, that's the conversion we're going to use. So we're going to take 3,600.8 inches cubed. 1 cubic inch equals 16.39 cubic centimeters, which gives us how many cubic centimeters? 59017.112. Now we'll just go 0.11. Cubic centimeters. Now, to convert this into kilograms from here is pretty simple. How many milliliters is that? A cubic centimeter is a milliliter. The definition of a milliliter is 1 cubic centimeter. So they're the same. If that's water, how many grams is that? The definition of a gram is the mass of 1 milliliter of water. So if we're dealing with water, 1 cubic centimeter equals a milliliter equals 1 gram. Now to convert that, so I don't know why I put the equal sign there, that's grams. Now to convert that into kilograms, What do I have? Now I actually do have to change it. What do I have to do? 1,000. Actually divide by 1,000. So just 3 decimal places. That is 59.02 basically kilograms of water. You guys remember the conversion between kilograms and pounds? Now you're thinking centimeters. 1 kilogram is 2.2 pounds. So if we take 59.02 times 2.2, we get 129.84. Now realistically, if I was looking for pounds, I would have found it from the cubic inches rather than going into centimeters, but just wanted you to be, this is what we were looking for, was the 59.02 kilograms. Once we got there, I just wanted you to be aware of what that really meant as far as how heavy that was. Okay, so today we have 2 things we're going to do. We're going to finish off our last real main topic for this unit. And we do have a quiz for you that I'll pass out here in a little bit. Then we're going to pass out the packet that we're going to be working on for the next couple of classes. Also kind of a review. Next Friday, then you'll be getting the unit test. So after today, it's kind of all review for the next 4 classes. Give you guys a chance to get all of any late quizzes and stuff in. Make sure we're going to look at your grades and stuff here before you leave today so everybody knows what you're missing. Because kind of Christmas is kind of my cutoff on makeup work. I want everybody caught up by Christmas so that we don't have to come back in January and rush in that 2 weeks before the quarter ends to get grades in. I don't want to see anybody fail this class because I don't want anybody getting bounced out of the program. So if I told you guys that I could throw a ball at the rate of 100 feet per second, would you believe me? No? Sure? Just because you're sucking up or because you really think I can do it? 100 feet per second, we really don't know how fast that is. Well, if you think about it, baseball field, it's 90 feet from first base to home plate. So 100 feet per second means you can throw the ball from first base to home plate in less than a second. So the question is that fast? Yeah, it seems like it, doesn't it? Well, we're used to seeing speeds expressed in what units? Miles per hour. So let's change that into miles per hour. To do that, we have to remember whenever we see a rate like that with the dual units, there's actually 2 numbers there. It's really 100 feet per 1 second. That's the key step. You have to be able to get it to that form. Now I have 2 different units I need to convert. I have to change the feet into miles. I have to convert the top unit, but then I also have to convert seconds into hours. I have to convert the bottom unit, the denominator. So let's do the feet first. The feet are on top, so to cancel them out, I'm going to put them on bottom. What am I converting feet to? Miles. What's my relationship between feet and miles? Well, the bigger one's the mile. 1 mile is how many feet? 5,280, correct. So the feet have canceled out. Now we don't need to calculate quite yet. We need to get rid of the seconds. Now the seconds are on bottom. To get rid of them, I'm going to put them on top. Now the next unit from seconds would be minutes. What's the relationship between seconds and minutes? 1 minute is 60 seconds. So I'm going to cancel out the seconds cross cancel. Right now, my units are miles per minute. That's close, but I want it to be miles per hour. So I have to get rid of the minutes yet. They're on bottom, so to cancel them out, I'm going to put them on top. I can go to hour. What's the relationship between minutes and hours? 1 hour is 60 minutes. So the minutes there cancel out. Now I have miles on top and hours on bottom, which is what I want. So let's go ahead and multiply. On top, we have 100 times 60 times 60, which is what, 360,000? Over 5,280, yes. What's that, 68? 68.2 miles per hour. When I was in high school, I could throw over 70 in the mid 70s, but 68, maybe if I did a lot of warming up, I could get there still. Only throw 2 or 3 at that speed, my arm would be shot. But yeah, I think 102 or 103 is the fastest clocked ball for a professional. Radar gun. Yeah, they do make balls with a chip in them that has a speed sensor in them that it reads off, but they're not legal to use in a game because you can't hit them with a bat. I keep waiting for them for golf to put a GPS chip in your golf ball. Really, I don't see why they can't. Yeah. That's how I don't keep score as far as over par or under par. I keep score as how many balls I lost. If I can make it through 9 holes and lose less than 3 balls, I had a great round. Yeah. I have not. Yeah. Yep. I've been known to hit a few houses. I would like to say the houses were close to the fairway. I would like to say that, but I can't. One house was like 40 yards off the fairway, and it was just an amazing slice. Oh, well. I missed the windows. That's what matters. No, I hit siding. I'm pretty sure, it was still pretty warm out. I don't think it would have cracked the vinyl, but it might have dented it. Down in Eau Claire, there's a little par 3. It used to be an 18 hole, now it's 19 holes. Well, they sold off the other 9 holes, and people built condos and houses there. And yeah, about at least once or twice a summer, a window gets punched out because I mean, there are houses literally like this far off the fairway in spots. I have no idea. I imagine at least 120. Yep. Yeah. Yep. Oh, sure. Actually, I got a friend whose kid loves to he's like 9 and loves to just tee off and hit balls. So what they do with him is they take him to a golf course up by Cumberland. Yeah, it's the Cumberland Golf Course. And Cumberland doesn't have any fields. I don't remember where they take him. They take him somewhere where there's fields right next to the fairways. And they just have him walk in the fields next to the fairways. He'll pick up a couple 5-gallon buckets worth of balls, take them home and hit them. Oh, sure. Yep. Oh, sure. I'm not one of those people that's going to crawl into the woods looking for a ball. And so, it's $1.50 for a ball. I'm going to stay up here and just drop one. Do you really think I keep accurate score and play by the rules? Yeah. I mean, technically, you have the choice of dropping or re-hitting from where you were at, or you're supposed to figure where it left. You know, it's in play and out of play. Where it left being in play, where it crossed the boundary. Even if it kept going for 20 yards after that, you're supposed to drop where it went out of play. I think you're allowed like 2 club links or whatever from the edge of the out of play. Okay, I need to focus a bit here, guys. So we'll bring it back in. So we got this one here, 42 yards per minute. We're going to convert it to feet per minute. So 42 yards per minute is 42 yards over 1 minute. Now here we only need to change one of the units. The minutes are going to stay the same. We only have to change the yards. Where am I going to put the yards here in my conversion factor? On the bottom. And what's going to go above it? Feet, good. The relationship? 1 yard equals 3 feet, or 3 feet equals 1 yard. Good. Yards cancel out, we get 126 feet over 1 minute, which is 126 feet per minute. We might have a roof load that is calculated as 120 pounds per square foot. And we want to figure out what is that in pounds per square inch, PSI. This conversion actually gets made quite a bit because your roof, your snow loads and all that stuff are calculated in pounds per square foot, but your capacity of your sheeting is in PSI, pounds per square inch. So again, 120 pounds per square foot gets written as 120 pounds over 1 square foot. In my conversion factor, which unit are we changing here? Square feet. So square feet can go top or bottom? Top, so it'll cancel. What goes below it? Square inches. What's my relationship? 144, there we go. 12 squared, or 144 square inches in 1 square foot. So square feet cancel out. We have 120 times 1. 120 pounds times 1 is 120 pounds. Over 144 square inches, which gives us 0.833 pounds per square inch. You got it. Let's take let's do this. Try to be nice. We'll do 3.2 ounces per cubic inch and change that into pounds per cubic foot. So we're back to changing both units here. So we write the 3.2 ounces per cubic foot, or cubic inch is 3.2 ounces over 1 cubic inch. We have to change both units, so it doesn't really matter where we start. Let's start with the ounces. So where are the ounces going to go in my conversion factor? On bottom. What goes above them? Pounds. Yep. My relationship? 1/16. Good. So that'll cancel out the ounces. Now we have to get rid of what do we still have to change? Cubic inches. Going on top or bottom? On top, because they're already on bottom. And what goes below? Yeah, we're going, denominator is cubic inches to cubic foot. There we go. Our relationship. the cubic foot's bigger. 1728, there you go. You had the right idea there, Logan, but you had to go times 12 again. You're thinking square inches. Yeah. So the cubic inches cancel out. On top, we have 3.2 times 1 pound times 1728, which is, what was that, 5,005.6 pounds over 16 cubic feet. So we divide that out, 345.6 pounds per cubic foot. That's pretty heavy. That's very dense. People think 3.2 ounces per cubic inch is not much, but it actually is. You guys know what density wood is per cubic foot? Depending, like balsa wood and some of the really dry light woods are like 28 pounds per cubic foot. It goes up to like 78 or 80 pounds per cubic foot. So that's less than a fourth of that. So realistically, wood is like 0.7. It's basically 3/4 of an ounce per cubic inch is what you're running. Let's say we have a pump that is rated to pump 5,000 gallons per hour. Is that a good pump? Now we're talking about like a sump pump for if you have a basement dug and you rains in it and you need to drain it out. Is that a good pump? Yeah. Well, we're used to see, what's that? Well, it depends on what you're using it for, yeah. But if you're draining like a foundation or a basement or whatever, those big pumps, usually they're 8 to 12 CFM. You know what CFM stands for? CFM is cubic foot per minute. So that's what we have to convert this to, is cubic feet per minute. So 5,000 gallons over 1 hour. Let's change the gallons first. Where do the gallons go here? On the bottom. What goes above them? Cubic feet. You got it. Anybody remember our relationship between cubic feet and gallons? 1 cubic foot is close, 7.5. 8 pounds of water in a gallon. So our gallons cancel out. We still need to get rid of those hours. Where are we going to put those? On top, so they cancel out. What we're going to put below them? Yeah, hours are going to become minutes. The relationship? 1 hour, 60 minutes. So our hours are gone. So on top there, we just have 5,000 times 1 cubic foot times 1. I'll do that one for you. That's 5,000 cubic feet. On bottom, 1 times 7.5 times 60 minutes. 450 minutes. If we divide that out, what do we get? $11.111111 cubic feet per minute. So that's actually on towards the high end of normal range of the 8 to 12, closer to the 12, which is good. So that is a pretty good pump. Any questions? Okay, it is a couple minutes early. Let's go ahead and take a break. Try one on your own here, one of these dual unit problems. I am going to have you convert (4.2), actually 2.4 is what I meant to put in there. 2.4 pounds per quart into ounces per cup. See what you come up with there. Okay, so let's take a look. So we've got 2.4 pounds over 1 quart. Let's change the pounds first. Pounds are going to go where? Bottom. What's going to go on top? Ounces. 1 pound is 16 ounces. Good. And then we get rid of the quarts. Quarts are going to go top. What goes on bottom? 4 cups in 1 quart. You got it. You noticed I used both of the conversions you just asked for? Okay. So 2.4 times 16 ounces is 38.4, thank you. Ounces. Over 1 times 1 times 4 cups is 4 cups. So we divide that out, it is 9.6 ounces per cup. Good. Now, what's that? Just works? No, anyway, so what happens then when we get into our metric units? There's 2 things that can happen. One is we have a mixture of metric with standard. The one thing that has never been metricized is time, because they didn't want to redo the way time was done worldwide. So we might have something like 48 meters per second and converting that into kilometers per hour. Well, there are 2 separate units here. There's the metric distance, but we have the standard time, seconds and hours. We have to convert each of those differently. Standard conversions happen like we did up here, using the conversion factors and canceling units. So let's do that part first. We have our 48 meters over 1 second. We're going to get rid of the seconds. Where do the seconds have to go? Top. I'm going to go directly into hours. 3,600, there we go. 60 seconds in a minute, 60 minutes in an hour. So we can do 60 times 60 is 3,600 seconds in an hour. So we converted the time. Now let's go ahead and just multiply this out. What's 48 meters times 3,600? 572.8? 172? Okay. Now what's a few 100,000 meters among friends? So 172,800 meters per hour at this point. Now we need to convert the meters into kilometers. So put the hours on bottom, kilometers are going to be on top. That's the units we want. Now notice I didn't leave room for a conversion factor. When we do metric, we don't need a conversion factor because we're just moving the decimal point. To get from meters to kilometers, we move the decimal point how far? 3. 1, 2, 3. That's 172.8 kilometers per hour. Is that fast, by the way? It's not slow. Well, let's take a look. If I want to convert that into miles, 1 mile is 1.6 kilometers. So that's 172.8 miles over 1.6 hours. We divide that out, we get what? 108 miles per hour. So it's not slow. If both units are metric, let's say we have 7.2 kilograms per liter, and you want to convert that into grams per milliliter. We don't have to use any conversion factors at all. We'll just write them out. 7.2 kilograms over 1 liter. And then we can just move the decimal points. We're going to grams and then milliliters on bottom. And I'm just converting to go from kilograms to grams. What do I have to do? How many places do I have to move? 3? No, grams are bigger, or kilograms are bigger. We're going to a smaller unit. And the way to remember what direction to move your decimal point, if the unit is getting smaller, the number has to get bigger. So going to a smaller unit, the number's going to get bigger, so it's 3 spots to the right. 7,200. Going from liters to milliliters is how many spots? In what direction? It's 3. No, liters are bigger. We're going to a smaller unit. Number gets larger again. So it's still 3 to the right. 1,000. 3 spots. So if we divide that out, 7,200 divided by 1,000, 7.2 grams per milliliter. Because the conversions are the same for every type of unit in the metric system, from kilograms to grams, kiloliters to liters, all that, it is very, very common to get this with a rate or a dual unit compound unit, where the number we started with is the same as the number we ended with, we just have different units on it. Here, because both of the units, there's 1,000 kilograms in a gram and 1,000 liters in a milliliter, or other way around, 1,000 grams in a kilogram, 1,000 milliliters in a liter, because both of them have the same conversion factor, the number didn't change. That's not always the case. We might have um, 2.8 grams per centimeter squared. We want to convert that to kilograms per meter squared. That's 2.8 grams over 1 centimeter squared. We're converting to kilograms over meter. I said squared. I wrote cube. It should be squared. Over meter squared. To go from grams to kilograms. 3 spots to the left. Very good. .0028 is correct. Kilograms. To go from centimeters squared to meters squared. Now, first of all, centimeters to meters is 2 spots to the left. Since it's squared, we go double that, exactly. So we go 4. So we go 1, 2, 3, 4, which makes it 0.0001. Then we divide those out to get 28 kilograms per meter squared. With our metric conversions, the number itself, the digits will be the same, it's just the placement of the decimal point is all that's going to be different. I'm going to have you try one of those in your notes. Let's do 63.8 kilograms per meter cubed. And we are going to go to milligrams per millimeter cubed. Okay, so 63.8 kilograms over 1 meter cubed. We have to convert kilograms to milligrams and meters cubed to millimeters cubed. How many places from kilograms to milligrams? 6 places. Good. We're going all the way from the left end of the chart to the right end. So go 1, 2, 3, 4, 5, 6. That is 63,800,000 milligrams. Is that correct? And then meters cubed to millimeters cubed on the chart, how many spots is that? Careful. There we go. It's meters, decimeters, centimeters, millimeters. It's 3 spots. But because it's cubed, we have to go, squared would be 6, cubed would be 9. So we have to add 9 zeros to the end of that. So that's 1 billion. When we divide that out, what do we get? .0638. Exactly, yeah. Okay, so there are pages out of your textbook that cover this. This is on the big book. Page 257, exercise 8-13A. And also on page 257, exercise 8-13B. Page 258 is exercise 8-14. And then also in that packet I gave you like 4 weeks ago, that's why I gave you pages out of the book, because I'm assuming you might not still have the packet. There's extra packet practice, page 91 through 93 in that packet. It would be the second of the 2 packets. So we'll give you a little bit of work time here on the quiz and on the homework. Let's get back here. If you guys give me a good 13, 14 minutes of work time, then we'll get out of here.